Okay, so we got to find these four answers for our trig functions. So just a review of yesterday, we've got two special right triangles that we're going to be working with. We have a 45, 45, 90. Across from the 45s are radical 2's. Across from the 90 is a 2. Then we also have a 30, 60, 90. Across from the 30 is a 1. Across from the 60 is radical 3. Across from the 90 is a 2. So those are the two special right triangles we are dealing with. Need to make sure we have them memorized pretty quickly. So the first one is sine of 150 degrees. So I've got to first figure out what a 150 degree rotation is going to give me. So if I rotate from here, the initial side to here is 90. So to get 150 degrees, I have to rotate an additional 60 degrees, which puts me here in the second quadrant. Again, if I rotated 150, that's 90 and 60. That means that my interior angle is a 30-degree angle. That gets me all the way up to 180. Okay, so this is a 30, 60, 90 triangle. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is a 2. And I'm asked to find sine of this angle. So sine is the opposite over the hypotenuse. So opposite is 1, the hypotenuse is 2, so it's 1/2. Now I've got to figure out, is this positive or negative? I'm in the second quadrant. All students take calculus. In the second quadrant, sine is positive, therefore my answer here is positive. Next one, cosine of negative 210 degrees. So now I'm rotating in the negative direction, which means clockwise. So this will be negative 90, negative 180. So to get to negative 210, I have to rotate an additional 30 degrees, which is going to put me here in the second quadrant. And again, if I went 180 here up to 210, that means this angle here is a 30-degree angle. So I have a 30, 60, 90. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. Now I'm asked to find cosine in the second quadrant. In the second quadrant, only sine is positive. Therefore, cosine, my answer is going to be negative. Now, cosine is the adjacent over the hypotenuse. So from here, from 30 degrees, my adjacent side is radical 3. My hypotenuse is 2. So that's negative radical 3 over 2. It just really doesn't like my ones. Any questions on either one of those two? Okay, next we're asked to find sine of negative 5 pi over 6. So again, you could convert this into degrees by using our pi over 180. Or I know when we're over 6, we're going in 30-degree increments. So I think going negative 30, negative 60, negative 90, that's 3 times. And then I've got to go 2 more to get to negative 5. So that's negative 120, negative 150. Which puts me here in the third quadrant. So if I rotated negative 150 degrees, then to get here is another 30 degrees. So this is a 30, 60, 90. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. I'm in the third quadrant. In the third quadrant, only tangent is positive, so I know my answer is going to be negative. Sine is the opposite over the hypotenuse. So from my central angle, the opposite is 1, the hypotenuse is 2. Therefore, my answer is negative a half. Okay, then the last one here, cosine of 7 pi over 6. So again, you could convert that into degrees. I know 7 pi over 6 is just a little bit more than pi, right? 6 pi over 6 would be pi radians. So I've going one more pi over 6 than pi. I know pi is 180, and then an extra pi over 6 gives me 30 degrees more. So I'm in the third quadrant. My interior angle is a 30-degree angle, or my central angle. So that's a 30, 60, 90 special right triangle. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. I'm in the third quadrant. Only tangent is positive in the third quadrant. Therefore, my answer here is going to be negative. Cosine is the adjacent over the hypotenuse. So my adjacent side is radical 3. My hypotenuse is 2. So my answer there is negative radical 3 over 2. Okay, so again, this is how some places teach you to do these problems. Instead of drawing your special right triangles every time, they teach you to memorize that unit circle. So you have that option if you do not understand the way I am teaching it, or you don't like to do all those steps that I do. You can memorize all of this. You make your own unit circle, and then you just answer it from the unit circle every time. Once you fill it out, you know that sine is the y value, cosine is the x value for each given rotation. So we will have a test on the unit circle where you have to fill out all of these values, but I never memorized them. I just drew my triangles every time, right? I memorized the angles. I know all my angle rotations. 30, 45, 60, 90, 120, 135, 150, 180, and so on. But I find them all using the triangles. So you can do that, or you could just memorize it. Okay, so here's 4 more, and these are going to be more mixed together. Where so far we've been looking at only the 45, 45, 90. Then we looked at 30, 60, 90, with the 60 being my central angle. Then we looked at it with the 30 being my central angle. Right here, they're all kind of mixed together. So you've got to make sure you know which triangle to use in a given situation. So the first one, it asked me to find sine of 420 degrees. So if I were going to work that problem out, I know that is more than a full rotation. I know 360 is all the way around. So I would find another terminal angle with 420. So you could do 420 minus 360, and you get the same thing as sine of 60. So sine of 420 is the same thing as sine of 60. So now I know I'm rotating 60 degrees, which puts me in the first quadrant. If I rotated 60 degrees up, then that means my central angle is a 60-degree angle. So it's a 30, 60, 90 special right triangle. Across from the 60 is radical 3. Across from the 30 is 1. Hypotenuse is 2. I am in the first quadrant. So all students take calculus. That means all of my trig functions are positive here. So I know sine is going to be positive. Sine is a ratio of the opposite over the hypotenuse. So the opposite side is radical 3. The hypotenuse is 2. So sine of 420 is radical 3 over 2. Okay, the next one, cosine of negative 240 degrees. So if I was rotating, negative means I'm going clockwise. So this is negative 180, halfway around. So to get to negative 240, I need to go another 60 degrees to get there. Which puts me in the second quadrant. And again, this was to 180. I had to go 60 more to get to 240. So that means my central angle is a 60-degree angle. So I'm dealing with a 30, 60, 90. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. I'm in the second quadrant, and I am looking for cosine. Cosine in the second quadrant is negative because only sine is positive there. So my answer is going to be negative. Cosine is the ratio of the adjacent to the hypotenuse. So my adjacent side is 1, my hypotenuse is 2. So that's negative 1/2. Okay, next, sine of negative 13 pi over 4. So I know pi over 4 is equal to 45 degrees, and I'm rotating in the negative direction. So I would go through and go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi, 7 pi, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4, 13 pi over 4 puts me in the second quadrant. Would be the way I would think about that. Again, you could convert that to degrees. You could find a coterminal angle. A lot of different ways you could do it. But that's the way I would do it. Now again, because I was rotating in terms of pi over 4, I know each rotation was a 45-degree angle because I have memorized pi over 4 is 45 degrees. So that means my central angle here is a 45-degree angle. So now I have a 45, 45, 90 special right triangle. Across from the 45s are radical 2s, and the hypotenuse is a 2. Now I'm in the second quadrant. In the second quadrant, sine is positive, and that's what I'm looking for, is sine of the angle. So I know my answer is positive. Sine is the opposite over hypotenuse. So the opposite side is radical 2. The hypotenuse is 2. So my answer there is radical 2 over 2. Okay, now if I was doing this last one, cosine of 11 pi over 6, I know 12 pi over 6 is 2 pi, which is a full revolution, which means I'm just 1 pi over 6 short of a full revolution, which is going to put me here in the fourth quadrant. So I needed another pi over 6 to rotate all the way there. I know pi over 6 is 30 degrees. So if I was pi over 6 short, then that means I was 30 degrees short of a full revolution. Therefore, my central angle is a 30-degree angle. So this is a 30, 60, 90 special right triangle. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. I am in the fourth quadrant, and cosine is positive in the fourth quadrant. So my answer here is going to be positive. Cosine is the adjacent over the hypotenuse. So my adjacent side is radical 3. My hypotenuse is 2. So my answer there is radical 3 over 2. Okay, so I've got a unit circle. Center at the origin, radius of 1. Okay, so this is any arbitrary radius. It doesn't matter where I draw the radius, I'm just going to draw it to the first quadrant. So I'm here, I know that that radius is 1. And I know I can make a right triangle from that radius. Now we talked about earlier, this distance here is just how far along the x-axis I went. This distance here is just how far along the y-axis I went up. Right? So this point here is the point xy. Okay, then we also showed you why x is equal to cosine of the angle theta. So let me label this angle theta. And y is equal to sine of the angle theta. Right, does everybody remember where that comes from? It's just a ratio of the opposite over the hypotenuse. So y over 1 is y. Cosine is the adjacent over the hypotenuse. So x over 1 is x. Now, what we can do is we're going to use substitution and the Pythagorean theorem. So what is the Pythagorean theorem? Well, it says for any right triangle, we have legs A, B, hypotenuse C. That A squared plus B squared equals C squared. Have y'all seen a proof of that before? Yes, no? I'll show you one in a second. Okay? But the Pythagorean theorem, the squares of the two legs, and add those together is equal to the square of the hypotenuse. Well, what we do is we use substitution. And x is equal to cosine of theta, so instead of x, I can say cosine theta. Y is equal to sine of theta, so instead of saying y, I could say sine of theta. So if I take my two legs, one's measure is sine of theta, the other is cosine of theta, and I add them together, I should get the hypotenuse. So the fundamental identity is sine squared of theta plus cosine squared of theta equals 1. And all that comes from is, again, the Pythagorean theorem. These are my two legs, and that is my hypotenuse. So right there where it says the fundamental identity, underneath that, you'd want to write that down. Sine squared of theta plus cosine squared of theta equals 1. And theta can be any angle. Okay, so the next thing they want us to talk about is the fundamental identity. So I'm going to show you where it comes from. You do not have to write this down. You don't have to know where it comes from. But I always like to teach where does something come from, because in my head that makes it make more sense in the long run. Okay, so if I have my unit circle, and this is going to be awful. I don't have my circle drawing tool. Oh, gosh, I can't even. I'm not going to be able to do it well, no matter how small. You know what? I'm just going to teach on the iPad. I'm going to get a circle on the iPad. How about that? Yeah, the radius. Yeah. I'm not even good at that. So, getting back over to this page, the fundamental identity is sine squared of theta plus cosine squared of theta is equal to 1. Now we're going to use that to solve our next two examples. So we could actually solve these without the fundamental identity, but we're going to go ahead and practice using the fundamental identity. It says use the fundamental identity to find cosine of alpha, given that sine of alpha is 3/5 and alpha is an angle in quadrant 2. Okay, so first thing I want to talk about, it tells me what quadrant I'm in. So because I'm in quadrant 2, I'm already thinking all students take calculus. In the second quadrant, sine is positive. I am asked to find cosine, so I know my answer is going to be negative because I'm in the second quadrant. So I already know it's going to be negative before I ever even start working the problem. Now, we know that sine of alpha is 3/5. So the same thing as sine of theta. We're going to plug in 3/5 here for sine. Now the difference is the formula has a built-in square. So we should be looking at sine squared. Okay, so plugging in, I've got sine squared plus cosine squared equals 1. Right, simple enough. Just substituting in algebraically. Now we're going to solve for cosine. We want to get cosine by itself. So first thing, 3/5 squared. That reduces. I'm going to have to rewrite this because I'm going to mess up my whole page. So give me just a second. So I've got 3/5 squared plus cosine squared equals 1. Now 3/5 squared is 9/25 plus cosine squared equals 1. It's still not going to let me do it. Okay, I'm just going to go sideways. Now I want to isolate cosine squared, so I move the 9/25 over and it becomes negative. So I've got cosine squared equals 1 minus 9/25, which means cosine squared is equal to 16/25. When we subtract that, we get 16/25. Now, we don't care what cosine squared is. We want to know what cosine is. So I would take a square root of both sides. When I take a square root of both sides, I have to always account for the positive and negative possibility. So that's where we get cosine is equal to plus or minus. Then the square root of 16/25. Well, the square root of 16 is 4. The square root of 25 is 5. So cosine is plus or minus 4/5. We know which one it is because it's in the second quadrant. That's what we established at the very beginning. It's never both the positive or the negative. It's always only one of them. And because we were in the second quadrant, we established our answer had to be negative. So my answer is negative 4/5. Okay, so the next one asks us to find cosine of alpha, given that sine of alpha is 1/3 and cosine of alpha is positive. Okay, so here's the information that we know so far. We know sine of the angle is positive. We know cosine of that same angle is also positive. So what quadrant am I in? Where sine is positive and cosine is positive. The first quadrant. So it doesn't tell me what quadrant I'm in, but it has to give me enough information for me to deduce it. Well, that's what I did here. Since they're both positive, I know I'm in the first quadrant. So I know in the end my answer is going to be positive. Okay, now plugging into the fundamental identity, sine is 1/3. So we're looking at 1/3 squared plus cosine squared equals 1. And same thing, we're just going to solve. So that's going to be 1/9 plus cosine squared equals 1. We move the 1/9 over. So that gives me cosine squared equals 1 minus 1/9, or 8/9. Now take a square root of both sides. So that's going to give me cosine of the angle is equal to the square root of 8/9. That's going to be 2 radical 2 over 3. And again, we would have to account for the positive and negative possibility, but we know it's positive because we're in the first quadrant. And it tells me that cosine has to be positive. So my answer here is going to be positive 2 radical 2 over 3. Now, I never can remember. If you put this in your calculator, does it give you this automatically? If you put square root of 8/9? Okay, so some of them will simplify as we continue this, and some of them won't. So if they don't simplify, just tell me, and I'll have to show you how to do that. Okay, so the next thing we're going to talk about are reference angles. Reference angles are always positive and acute. So acute means they are between 0 and 90 degrees. They're formed by the terminal side and the positive or negative axis, x-axis. I should say x-axis. So what this is fixing to do, we're going to be finding the angles, which is the way I've been teaching it already. So this should not be that new to you. The way I've been drawing triangles is I've been finding reference angles. So as we work these, you'll see that you've kind of already done this. This is why, if you remember, I said I don't know why we haven't taught this first, because I would teach this first if I were doing this. So the reference angle for each of the following, so for negative 300 degrees, so I think about that rotation. Negative means I'm going clockwise, so this would be negative 90, negative 180, negative 270. So negative 300 puts me here in the first quadrant. So if this was 270 and this got me to 300, that means this angle is 30. So what is my reference angle or my central angle? It would be 60 degrees. So the reference angle for negative 300 degrees is a 60-degree reference angle. And that's what we're going to be doing on all of these, is just like that, thinking through. Okay, the next one, 5 pi over 6. So because it's in radians, again, you got different ways to think about it. I know pi over 6 represents a 30-degree increment. So if we wanted to count, this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. I would still be in the second quadrant. And again, I rotated 4 pi over 6 and 5 pi over 6. So I rotated 60 degrees to get here, which means my central angle is a 30-degree angle. So the reference angle for 5 pi over 6 would be 30 degrees. Okay, the next one's negative 15 pi over 4. So again, different ways you could do it. You could count it. If I was working this, I know that's really close to 16 pi over 4. 16 over 4 is 4 pi. So that would be 2 full revolutions. And again, because it's negative, we're going in the clockwise direction. So this would be negative 2 pi. This would be negative 4 pi or negative 16 pi over 4. And I am 1 less than that. I'm only at negative 15 pi over 4. So I would back up a pi over 4 to get to negative 15 pi over 4, which would put me here in the first quadrant. Because I backed up a pi over 4, which is 45 degrees, that means my central angle here is a 45-degree angle. Therefore, my reference angle is a 45-degree reference angle. And the last one here is a 390-degree rotation. So again, 360 would put us all the way back to here for a full revolution. So I would need to go another 30 degrees to get to 390, which means my central angle is a 30-degree angle. So my reference angle is 30 degrees. Okay, so what I have to do is I have to substitute in for theta 11 pi over 2. So this is where I used to always get confused when I would have a fraction inside a fraction. So again, you may already know what the answer is, but I'm going to talk through how I would have done it when I was in school. So this would be 11 pi over 2. That's my theta, and that's going to be over 2. And I'm going to put that over 1. So now I have 11 pi over 2, and I'm going to multiply by the reciprocal because I can't divide a fraction by a fraction. Now 11 pi over 2 times a half, we multiply straight across, so that's going to be 11 pi over 4. So I am actually just finding sine of 11 pi over 4. So if I were working this out, 8 pi over 4 is the same thing as 2 pi, so that's a full revolution. So this would be 9 pi over 4, 10 pi over 4, 11 pi over 4. Puts me here in the second quadrant. I know when I'm rotating by pi over 4, those are 45-degree increments. So I have rotated an extra 45 degrees, which means my central angle, or my reference angle, is also 45 degrees. So this is a 45, 45, 90. Across from the 45s are radical 2s. And the hypotenuse is a 2. Sine is the opposite over the hypotenuse, so that's going to be radical 2 over 2. And I'm in the second quadrant. All students take calculus. In the second quadrant, sine is positive, therefore my answer here is positive. Radical 2 over 2. So now inside my argument, I have two angles that are being added together. So if I were asked to do this, I would convert these into degrees, and then I would add the degrees up. So both of these are ones that you'll eventually have memorized if you don't already. Pi over 2 is a 90-degree rotation. So you can either convert it or, again, know that one. And then pi over 6 is a 30-degree rotation. Again, another one you should have memorized. So I'm actually just finding sine of 90 plus 30. So we can go ahead and add that because that's in the argument together. So I'm actually just looking for sine of 120 degrees. So I'm going to go ahead and rotate that. This would be a 90-degree rotation. So a 120-degree rotation would put me in the second quadrant. So if this was 90, to get to 120, I rotated 30 here, which means I have to rotate another 60 degrees. So my reference angle or my central angle is a 60-degree rotation. This is a 30, 60, 90. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. I'm in the second quadrant. All students take calculus. So my answer is going to be positive. Sine is the opposite over the hypotenuse. So that would be radical 3 over 2. Now the last one we're going to work is 1 minus cosine of 7 pi over 6 divided by cosine of 7 pi over 6. So I need to go ahead and find what cosine of 7 pi over 6 is. They actually did us a favor this time because both of them are the same angle and it's the same trig function. So I would go ahead and find that value. So 6 pi over 6 is the same thing as pi. So if I go 7 pi over 6, I'm going 30 degrees more than that, which means I'm going to be in the third quadrant. I rotated an extra 30 degrees to get there, so my central angle is 30 degrees. So this is a 30, 60, 90. Across from the 30 is 1. Across from the 60 is radical 3. Across from the 90 is 2. I'm in the third quadrant, so all students take calculus. That means cosine is going to be negative here. So my cosine, so let me just write a little note down here. Cosine of 7 pi over 6 is going to be negative. And then cosine is the adjacent over the hypotenuse. So my adjacent side is radical 3. My hypotenuse is 2. So everywhere I saw cosine of 7 pi over 6, I'm going to substitute in a negative radical 3 over 2. So plug that into my original now. So that's going to give me 1 minus negative radical 3 over 2 over negative radical 3 over 2. Okay, so let's clean that up. First thing I notice, I've got a minus a negative, so I'm going to fix that into a positive. So this is 1 plus radical 3 over 2, and this is divided by negative radical 3 over 2. So now I have a fraction divided by a fraction. So before I can multiply by the reciprocal, I need to get a common denominator in the numerator. So here in the numerator, I've got 1 plus radical 3 over 2. So I can put both of those as over 2. So that would give me 2 over 2 plus radical 3 over 2 all over negative radical 3 over 2. And then we want to write that as a single denominator. So my next step would be that is 2 plus radical 3 all over 2. And then this is divided by negative radical 3 over 2. Now I have a fraction divided by a fraction, so I'm going to multiply by the reciprocal. So that's going to be 2 plus radical 3 over 2 times 2 over negative radical 3. Now I can cross reduce when I multiply, so this 2 and this 2 goes to 1. Now I cannot reduce the radical 3's because this is a binomial. It's two things being added, while this is a monomial. So those don't reduce, so we leave it as it is. So that's going to give me 2 plus radical 3 over negative radical 3. Now we're not allowed to have a radical in the denominator, so I need to rationalize the denominator. So your calculator may do that for you, I don't know. But if I have to get rid of a radical 3, then I need to multiply by radical 3 in the numerator and denominator. So now, while we do that, is in the denominator, radical 3 times radical 3 is just 3. And then in the numerator, I distribute that. So that's going to be 2 radical 3 plus radical 3 times radical 3 is just 3. And don't forget there was a negative down here, which I almost did forget. So this could be a final answer. But we normally don't put the negative in the denominator, so I would pull the negative out in front. So do like negative 2 radical 3 plus 3 all over 3 would be the way I would write that. So yeah.